Hello, party people. It is Miss Press here. We are doing some algebra today, and today we are covering topic 2I, right? Systems of two linear equations given a table of values, a graph, and verbal description. So this is going to be a lot like 3C, no, 2C, but it's just leveled up. We're doing two equations at the same time. And there are three main ways we're going to see these. We're going to see these in the forms of tables, in the forms of word problems, and in the forms of graphs. I want to start with graphs because this is by far the quickest that we're going to solve. I highly recommend, and this isn't the only way, but I highly recommend when you see a graph and you see some equations, the first thing you're going to do is plug them in your calculator. So when you see a graph, you're going to remember graph equals calculator. I'm going to plug them in my calculator and check them. Now, I have to put them in function form in order to get points, but a couple things I can check if I don't have them in function form are the x-intercept and y-intercept. I can compare those to what I have on my graph to see which one checks out. All right, blowing past that because that is a piece of cake, I want to go into a word problem, which tends to be a little bit trickier. Now remember, when you're going through a word problem, you really want to mark things like important numbers and what those important numbers signify. That's a really important trick. So mark the important numbers and what those important numbers signify. That's going to be our B, box important numbers. E is going to be where we emphasize our keywords. For example, the total value of the coins is $2.85. A is where we're going to analyze our givens and unknowns. So these are the pieces of information I'm given. I want a system of equation, that's my unknown. R is where I'm going to reread the entire problem. And then S, strategize, solve, and check. So in the case of this problem, I went through it really, really fast in my head. I would have read it out loud, but I'm short on time for this video. I would see quarters, dimes. I can see those two in my problem. It says there's a total of 18 coins, and the total value of the coins is $2.85. So I know that the number of quarters plus the number of dimes should equal 18, which means I can eliminate this. There are not 2.85 total coins. I can also eliminate this one. That leaves me down to F and H. Now what's the difference between F and H? Well, I'll notice there's a piece of information here that I wasn't given in the problem. You might need to know how much money each coin is worth. A quarter is worth 25 cents and a dime is worth 10 cents. So if you're not familiar with your coins, definitely brush up on that because you might see problems like this, although most of the time you'll be given those values. I need to make sure that the value of each coin is aligned correctly. If I look at this, it says 10 cents for each quarter and 25 cents for each dime is going to give us our total value, and I know that is not correct, so it has to be H. Last but not least, you might see tables of values. Now, you could use each table to try to construct an equation using your slope form and point slope form. However, I personally think that the easiest way to do this is just to pick an x and a y from each problem and plug them into the equation. Then you can have your calculator test them out for you. For example, here I could plug in 7 equals 1.75. I'm plugging in 2 for x plus 3.5 to see if that gives me a statement of true or false. And what's really important is that once I determine whether the first equation is true or false, I need to look at the second as well. So that's going to give me 4 equals -4 times -3 minus 8. And again, plugging that into my calculator to see if it tells me if it's true or false. Now, in this case, my first answer choice both happens to be true. I recommend checking each one. Another important point here, I put my x and y in parentheses. That is a critical step. You have to put your x and y in parentheses because in cases like this where I'm multiplying, I don't want to confuse myself and make this 1.752, 1 and 752 thousandths. I want to make sure that I remember that this is 1.75 times 2. All right, and so those are the three main ways you're going to see systems of linear equations. Also remember, in a system of linear equations, one thing that we didn't talk about is the solution. In fact, you can use